The next property is could not give it a name property. So what do we have over here? We have the function f of x dx integrated from 0 to 2a, right? 0 to 2a. This is equal to integrating the same function from 0 to a, not 2a, plus 0 to a again. But here the function is, first one, we have the function to be f of x, but here the function is f of 2a minus x, right? So let me show this. So this is our original graph. This is our LHS. And the area is approximately 2.5. This is our RHS. Here and with this, we can see that it's the same structure, is it or not? Right? It's the same thing. And we have the area approximately 2.5 again. So we have the same thing. Now the question is, how did it work? So let me show that in this code, we have done the same thing. So we can see that we have two set of things, that red and the green one. The red one is the first part and the green one is the second part. In the second part, we have 2a minus x. Okay, so that would be, 2a minus x, right? End here stands for a. I could have used the variable a itself. So, but I used end, ending. So this is 2a minus x, right? And I'm adding the areas over here. You can see that I'm adding the area. Total area is calculated this way. Let me prove it mathematically and I'll explain it graphically also. Why does it make sense? Okay, we have the LHS 0 to 2a f of x dx, right? So we can split it as 0 to a f of x dx plus a to 2a f of x dx. Now we need to manipulate this. That's the one which has to change, right? So we'll consider that. So we'll consider integration of a to 2a f of x dx. So we can tell let x be equal to 2a minus t, and so t will be equal to 2a minus x. It's better to have both the expressions. So dx will be equal to minus dt. Now for x is equal to a, if I substitute x is equal to a, what happens over here? T will be equal to 2a minus a, that is a itself. If x is equal to 2a, the upper limit, then t is equal to 0. 2a minus 2a is 0. And so we have the integration from a to 0 f of 2a minus t dt, right? Sorry, minus dt, my bad, minus dt. The minus comes from dx is equal to minus dt. Okay, so hopefully no doubt. Now the next thing is we need to, one last thing, I can do it here itself. I can, using the second property, I can do this 0 to a f of 2a minus t dt, right? Minus of this will flip across and we have it from 0 to a. Agree? If I substitute it over here, we are done. So therefore LHS is equal to 0 to a f of x dx plus 0 to a f of 2a. Oh, I forgot. There's one more step. I need to change the variable. This is 0 to a f of 2a minus x dx. This is from the property 0 and this is from property 1. This is property 0 and this is property 1. Agree? Okay, we're almost there. And finally, we can tell that, therefore, x into dx. And this is equal to our RHS. And we have the proof. Right? So let me explain the reasoning behind it. I would like to make use of the graph. Of course, mathematically we saw the reasoning. Let me explain it graphically also. What does it mean? See, if you put the values right, the first integration is this and second integration is this clearly. Okay, second integration is not clear, but first integration is clearly this. This being the 0 and this being the a. Right, and the integration starts from 0 to a. Now, the second part, f of 2a minus x. See, if I substitute 0 over here, what will you get? F of 2a, 2a at this point. Right? That is f of 2a at this point. And as and when I substitute, obviously it will keep reducing. Right? This expression keeps reducing. So the starting point is this. This is the start. And the end will be what? Obviously the end will be a. Right? When you substitute a over here, 2a minus a is f of a. So basically we are moving the other way around. Agree? That's it, as simple as that. Okay, so this is 0 to a, and here it would be 2a to a, other way around. It doesn't matter how we add it, right? End of it we get the same answer. So graphically this is how I can explain it as. And finally I think we'll talk about an example and we'll wind up the video. So say 0 to, it can be anything actually. Say 15. X square plus 3 dx. So this would be equal to 0 to 15 by 2 x square plus 3. So that's our integration dx plus 0 to 15 by 2 again. But over here it is 15 minus x the whole square plus 3, open and closing the brackets, dx. Okay, again, how is it useful? We'll see all of that in time. For now, learn the properties and also execute the programs and try to understand on your own as well.